Good morning, DEFCON. You are the hardcore Sunday morning, right? Come on, let's go. All right, you may have heard of mainframe pen testing and exploitation, mainly from our next speaker. DEFCON, please give a welcome to the soldier of Fortran.
Wow, that was awesome. The other room cheered for me. That was great. Morning, everybody. I really appreciate y'all coming to a Sunday morning talk at DEFCON. Front row, I'm going to need your help. I can't see anybody else. And if my hand starts to drop and you can't hear me anymore, can you guys just be like, hey? Thank you. Thank you so much. All right. So, for those who don't know, my name is Phil Young. I'm the director of, we'll just wait for them to calm down. I don't know what's going on over there. So I'm the director of mainframe pen testing at NetSpy. You might also know me by my other name, Soldier of Fortran. I was a mainframe hacker, like a 90s hacker kid. I was a mainframe security enthusiast before I started doing this professionally. I'm a terrible karaoke singer. And just so folks know, like I always felt like an outsider, especially even in this community. This is my third time speaking at DEFCON, and I still sometimes feel like an outsider. So if you feel like that, that's everybody feels like that. And I've been doing like professional mainframe pen testing for about 10 years. This was supposed to be a co-talk, but unfortunately my co-speaker is no longer with us. He had to go home to take care of his kid going to college, so he's not here. So, but still gonna talk about him. So he was a 90s hacker kid. He was also a mainframe security enthusiast. He loves show tunes. He's really good at reverse engineering things, probably the best reverse engineer I know, especially when it comes to mainframes. Dude's a freaking genius. He's also been testing mainframes for 10 years. Now there's a third person in this photo who we didn't invite, but he's the OG mainframe hacker. And we wanted to make sure we shine a light on him as well. Before Chad and I came along, he was like the only mainframe hacker who was publicly talking about how to do like mainframe pen testing, right? At mainframe conferences, not places like DEFCON. I've been trying to get him to come to DEFCON for years. But I want to make sure we talked about him because he is the OG for mainframe hacking. Now, since Chad and I have been friends for the better part of 10 years, I need help with my code. I'm a great coder, especially when it comes to assembly. And so I will oftentimes send my code to Chad so that he can help review the code because it doesn't work, right? And every time I send him a piece of code, he puts me on blast on Twitter first. Then he fixes it. Speaking of Chad, since Chad couldn't be here, what I did was I told him, hey, send me like 10 to 15 photos of yourself. Not telling him what they're going to be for. And then I said, hey, I want you to give me quotes that I will put in the talk. Okay, so remember this slide. Look at the bottom where, and yes, I did write that. I hope it's enough, okay? And now when I sent Chad the deck and I said, hey, I want you to put inspirational quotes or technical quotes, but I mistakenly told him, I will read off whatever you put verbatim. So the first thing he sends me with respect to this slide is he said, it was not enough. So thanks, Chad. I appreciate you. This is not so bad. I can actually see a bunch more of you than I thought, so we're going to try this out. Who here can tell me where the mainframe is in this picture? Don't be shy. You can just yell it out. The system, you got to be, someone said system in the back. Can you be a little more specific? Where the tapes are? No. Yeah, this guy put his hand up, yes. The red box in the corner that says 360 on it, yeah, that's the mainframe, right? That is the mainframe. The reason it's called a mainframe is because it holds all the CPUs and memory, right? It is the main frame, that's where the word comes from, where you host all the CPU, all that stuff. The rest of this is just I/O, right? You've got your terminal, you've got your card reader, you've got a dude pressing buttons for some reason, right? But everything in that one thing, that's the mainframe. Now, today, in a modern data center, this is what the mainframe looks like. It's exactly the same, thank you. The only difference is this is the mainframe. And now this one box, I promise you right now, there is a box exactly like this in some bank or some airline's data center, and it is processing thousands of transactions a minute right now. And it's doing it flawlessly, and it's the workhorse of the enterprise. And lots of enterprises still rely on this platform. You have no idea how many articles come out. Mainframe's dead. Mainframe's going away. This company's moving off the mainframe. This other company's moving off the mainframe. There's so many announcements, this company's moving off the mainframe. There's never announcements, we successfully moved off the mainframe. Okay, they never do. They start, some CIO comes in, starts the process, they get about halfway, and that CIO quits, right? That's usually the steps. But so many companies rely on this platform today, right? You've got airlines rely on it. I mean, if you flew on any of the major airlines, a mainframe was processing your transactions. Every time you use your credit card or debit card, mainframes are involved in some capacity, right? Auto manufacturers, obviously banks, but even companies like UPS use mainframes. If it's older than, say, it's like a 50-year-old plus company, guaranteed they're using a mainframe, okay? Before we get too far into the talk, I need to talk about some terminology that's important for y'all. So, RACF is what's called a external security manager. So there's actually 3 of them, RACF, Top Secret, and ACF2. Now, it's called external security manager even though it runs on the mainframe as part of the operating system. But think of it like Active Directory if you could replace Active Directory with something else, right? Better or worse. It's the same concept, right? So the reason is the operating system itself doesn't really care. It just asks what's called the SAF router, and it says, hey, is this okay? And then the router knows which product to route it to. You can only run one at a time. So that's RACF. Now, RACF controls sort of all the security permissions on the mainframe. In RACF, there are user attributes called special and operations. Special and operations allows you to edit any file, to change any file, to give yourself whatever permissions you want in the RACF. If you have system special but not operations, you can give yourself operations, right? If you have operations but not special, you can download the RACF database and crack all the passwords, right? So either or gives you complete control over the system. APF libraries are, imagine if you had a folder where you could put set UID. Any program you put in there was automatically like set UID, right? Very similar concept, but you can get into essentially ring 0 so long as you put your binaries in there, right? That is the control that mainframes use. Basically, when you put a program in that folder, it is allowed to run in a supervisor state with the CPU. That's what it means. That's how they control how programs can run. Key 0 is this is all terminology you need to know. Key 0 is every page of memory has a key. Key 0, if your process is running in key 0, you can edit any location, any page of memory you want. Otherwise, the only other time that works is if your keys match, right? So if I'm in key 8 and the memory space is in key 8, then I'm allowed to edit that region of memory, but if not, I can't. Now, we would like to think that, these are all myths about mainframes, right? But when it comes to these myths, this is a slide that Chad gave a talk on 10 years ago. And even today, we keep hearing about these myths, right? It is crazy. Okay, so there's really 4 main attack paths on the mainframe. You get your network attacks, right? Normal network type attacks, right? Nmap works fine, all these things. On top of that, though, we have SNA networks. So that's a completely different type of network that runs. We have the file system, right? You'd be surprised. Sometimes on pen tests, I go in and I see I have like write access to 30,000 data sets, or read access to like sensitive company information, like 110,000 data sets. It's crazy. External security manager, that's the other attack path. That's where we go in and we look at, do I have access to this? Do I have access to that? And in fact, some of the things we're going to talk about today are because of misconfigurations in the external security manager. And lastly, what this bulk of this talk is about is ZOS Unix. And the reason we wanted to talk about ZOS Unix was because we used to joke that like Unix was the gateway drug to mainframe hacking because it's so familiar, right? It is such a familiar thing to you, especially if you use Linux. In fact, I have a pretty good view of the audience. Can I have a show of hands who's familiar with Linux? Right, like most of the audience, right? So that's good because it's very similar, but also a little bit different, right? So it's based on System V, right, or System 5, and it really didn't get built out until mid-90s, right? So the IBM operating system is called ZOS, right? So it runs ZOS, and inside ZOS, you run Linux, or you run Unix, sorry. It was developed in 1994. It wasn't really a core part of the operating system. It was based on like Unix from Bell, those kind of things. In 96, it obtained POSIX compliant, and it took over running TCP/IP for ZOS. Prior to that, it was all jobs and stuff, but instead they just built the TCP/IP implementation on Unix. They rebranded it in 98 to Unix System Services, and it continued to grow a little bit more. And then today, they rebranded it again to ZOS Unix. And for those curious, Linux was released in 91. So just a little timeline. Now, when it comes to Unix, again, it's like Linux. It's a little bit different. You only get 2 shells. bin sh, which sucks, bin tcsh, which sucks a little less. Right? They're both not great, but that's all we get. Look, everyone here knows Linux. I'm not going to explain how file systems work in POSIX environments. You get file permissions, right? Regular file permissions. But here's where it gets a little funky. You can also have other permissions that you put into your ESM, right? Like recf. So you can have, say, I have read access to this file according to the file system, but when I try to read it, recf says no, that folder is only for admins, right? Where that gets challenging is sometimes you can mix those up and not do a great job. You access the Unix environment. There's a whole bunch of ways to access the Unix environment. You access it through the OMVS command in TSO. So I'm not gonna say, there's whole other talks about hacking in TSO, but like you just type OMVS and you get like a Unix prompt. SSH sessions, which is what we're gonna use for this talk, right? Because we're trying to demonstrate how you can do all of this in Unix. Or you can use JCL, you can use BPX bash, you can use Rex scripts, you can call it from C programs. There's all kinds of things you can do, assembly programs, right? I know Chad wrote a module for Metasploit that spawns a Unix shell using assembly. So you can call it all kinds of ways. What's interesting is you can also access data sets from within Unix using this super funky command, right? So you do like // then the name of the data set you want to interact with, and then you pipe it to, that's where you're copying it to. It's frustrating because only a handful of commands support it, and it's not clear. So like, I know copy works. I know cat works because the client I was on wouldn't let you copy a data set. So I just catted it and piped it out, like redirected the output. grep does not support it for some reason. So it just sort of like depends on what IBM wanted to do. Now, again, if you're familiar with Linux, this should all be very familiar, right? Close enough, right? You've got normal commands, you've got your normal stuff going on here, you can cat files. The fact that it's POSIX compliant means you can do all the normal things you can do in a Unix environment, right? It's not some crazy thing going on. Okay, so here's the next Chad quote. I can see it on my screen here. I don't. Ask me about Vegas, Phil. That's it. So I'm not going to leave time for questions, just so you know. So good luck. All right. When we made this talk, we wanted it to sort of walk you through step by step how we do a pen test, right? Because there's lots of tools and stuff that exist now that we didn't have, like 10 years ago. And it's important to understand how we start, because like jumping in straight to the end sucks. So there's a whole bunch of tools that exist today. These didn't exist 10 years ago because Chad and I wrote them, right? So you have You have a tool called enum. That's a Rex script. So for those who don't know, Rex is a scripting language. Actually, quick question, who here ever used an Amiga? Yeah, that's way more than I thought. So Amiga came with Rex. But Rex is a scripting language. It was created by IBM as a 10% project. But anyways, Rex runs in Unix natively, and so we write a bunch of our scripts in Rex. We also have another script called OMVS enum, and that script is based on linenum. I'll get to that script in a bit. We also have a couple of Java tools called file traversal and Zosshog. Those allow us to sort of map out the file system, like do we have read access? Are there passwords in them? And then we have another tool called port scan, which we'll talk about when we get to egress. All of this is freely available on my GitHub. So if you wanted to test them out or play with them, they're freely available, right? And if you have a keen eye, you may have saw there was a file called all.jcl. Getting things onto the mainframe during a pen test can be very challenging sometimes. Uploading multiple, if you have to upload one file, it's a pain. If you have to upload multiple files, it's a bigger pain. Companies, for some reason, try to limit your ability to upload. There's always a way around it, right? There's always a way around it. So what we do is we package everything up, all of those scripts, into one JCL, and then it just runs by itself. It adds all those programs. Now, how do we get it to the mainframe? You can just use SCP. Problem is, SCP only supports binary file transfer. And I'm sure as you're reading the slide, you're kind of seeing why. Does anybody want to guess why that's a problem? Okay, yes, a hand up. You don't have to yell because there's yes, character encoding. So code pages. Our files written in ASCII or UTF-8, the mainframe speaks EBCDIC. So we have to convert it to EBCDIC. So that's what we do, and then we upload it, and it's all good. For the purposes of this talk, whenever you see the blue prompt, that's when we're in Linux. So we're doing something to prep. That's our staging. If you see this prompt, that means we're on the mainframe, okay? Now, let's take a look at enum. So this is that enum Rex script. So what this script does is it pulls information from memory. So it does a really good job of accessing things from memory, because we have read access to a lot of memory space. And it dumps information out about the operating system, about the current running environment. And it's been built, it wasn't just me. There's other people that helped JT and other people who have helped build this. Some things in memory are not documented. And so we sort of reverse engineer those. And what's interesting about this program is sometimes you're limited. You can't list these things. But it exists in memory if you know where to look. So that's what this Rex script does. This Rex script pulls out all kinds. I use it on every single pen test. The next script we have, the next thing we have is OMVS enum. It is based on linenum, okay? But I had to rewrite it for TCSH. And then what we did is we added a whole bunch of mainframey type stuff to it. So you'll see us running it here in a second. And if you're wondering why it's going to be OMVS sed here, you can come talk to me after. But we're going to run it. We're going to tell it to send it to a report. And what's going to happen is it's going to go through and dump all kinds of information, right? And you'll see some more mainframey stuff. So the stuff that's going to be in all caps here in a second, that's a list user command from RACF, right? So it dumps all kinds of information, and then we comb through it later. The other thing we always test for is egress busting. You would be surprised how often we're able to go directly from the mainframe behind. I have to go through 2 VPNs sometimes to even touch the mainframe. But we're able to go from the mainframe directly to AWS or some other cloud provider, right? It is crazy how often that works. And so, in fact, one of my clients, we did the test. I wrote it up saying, hey, you have thousands of ports are allowed to no egress filtering out to this AWS host. And they go, we haven't used that ISP for 10 years. We have no idea how this is routing, right? So anyway, it's not really that hard. We use a Java program. The reason it's written in Java is most mainframes come with Java, right? By default. Also, it allows us to control the timeout of the packets. And then we just do a port scan, essentially a SYN scan. And then on the Linux box, we run a tool called Egress Tester, which is a fork of Egress Buster. And you can see all the open ports. OK, next picture of Chad. He wanted me to say that I sent him this hat after I told him, after he told me he bought a boat. That's a true story, actually. He bought a boat, and I was like, you know what he needs is a dumb hat with hair, because he does not have hair. Okay, let's talk about some analysis. So now that we've done the enumeration, we've gone through the enumeration, let's look at some of the output. This is from enum.rex, okay? And the important bits that we pull out of that are the location of the RACF datasets, and the fact and what hashing algorithm they're using. Okay, RACF uses either DES for the hashing algorithm or KDF AES. John the Ripper and Hashcat both support cracking RACF databases. And if you have read access to either of those two data sets, it's trivial, especially since we know that KDF AES encryption is not enabled. It's trivial for us to crack every single password in that database. I think Chad was telling me a story where he downloaded the database, cracked it in maybe an afternoon, like 2-3 hours, had every single password for every single user. Okay, so if you do run a mainframe, please make sure you turn on KDF AES. Now, when we look at the OMVS enum output, we see there's a bunch of stuff here, right? We can sudo root without a password. And we'll talk about that in detail. Files that should not be world readable, like someone obviously chmodded some stuff 777. We can mount. We can mount data sets, right? Which you can normally do, but this one gives us more access than we should have. And this last one is we can issue the extattr plus a command. Now, the other tool we ran that gave us some interesting output was ZOSHOG. ZOSHOG is based on TruffleHog, and it uses regex to find secrets inside files in Unix. And when we ran it, obviously we found a password. All right, here's the next one. God, I hate this one. Ask Phil to pronounce Java and then wiki. Java wiki. I don't think I say it incorrectly. All right, next is privilege escalation. So now that we know what's wrong, right? We know there's some vulnerabilities on the system. We definitely have to demonstrate impact. Especially when it comes to mainframe hacking, you have to show impact because not every time, I would say 99% of the time, my findings are an uphill battle with the mainframers, okay? I get so much pushback, you have to show like, no, actually this setting is very dangerous, look what I did, okay? So let's talk about privilege escalation. Obviously the first one is the super easiest one. We found stored credentials, okay? So this could be lateral movement. 9 times out of 10, it's not. So, and I would love to say this is a rare thing that I've only found once. No, I found this multiple times, okay? So, do not store password in files. Obviously, if you have to, make sure the permissions are correct, and make sure you test those permissions because maybe your ESM, like RACF, is overriding those permissions and everyone has read access to it. So this is an example. This is an actual example from a client. Obviously not, I rewrote it. It's not their work. But it's very similar, and we found a script like this in the user's home folder, and it was chmodded 777, obviously because it wasn't working until someone did that, right? And then all of a sudden it started working. It had user credentials in it, and so super, super easy hack, right? Guys, mainframe hacking is not hard. It's not that hard. We just SSH in with the username and password, right? Like this is not rocket science, right? We type their username, we type their password, and then we get in. And the first thing you do once you connect is you make sure you know who you are, right? So, okay, I'm logged in as me. And then we have some fun. And then the next thing we do is we run the command list user, okay? Because that actually tells us what we can do. And if you'll notice, this user has special in operation. So at this point, it's game over. We can kind of do anything we want. And the pen test turns from a pen test to now an assessment because we can read everything. Oh, great. This one's finally one not about me. He wanted me to tell you that Mark, from that intro, drove his Aston Martin into a washed out area of a road and had to climb out the window and be rescued from the roof. I asked him for technical quotes or inspirational quotes, and this is what he gave me. Okay, the next one we're going to talk about is this one at the bottom because I know none of you know what extattr plus a does. That is only on the mainframe command, and it's very important to understand. So, remember we talked about APF authorized programs? So APF authorized programs are allowed to get into supervisor state. That's what they're allowed to do, right? And that comes with a bunch of different things. On the regular mainframe side, you have to put them in an APF authorized program library, otherwise known as a folder. On Unix, you can actually assign programs the extra attribute A that makes it APF authorized, right? That's all that does. Okay, so the access to control that is bpx.file. I know it says extra, but it's file attr.apf. So read access to that profile in RACF lets you issue this command. Most people should not have access to do that. Now, why is it important to get APF authorized? I'm going to walk you through what happens when you log into the mainframe and why getting APF authorized and all this stuff is important, because it's the thing I didn't understand. So when you log in, the first thing the operating system does after you log in is that RACF copies a bunch of user information about you into memory, right? And it refers to that memory region. Think of this like your ID, like your ID in Linux, right? And if you can change your ID to something else, right? Similar concept. So it sits in memory. Problem is, that memory region is locked under key 0. And user processes only run under key 8. So we cannot change this region of memory. If we could take over the mainframe, right? If there's a way for us to change our key to key 0, then what we do is we just replace this. It's called the ACEE. We replace our ACEE with whatever user we want that exists on the system. And now we can become someone else, preferably an admin. But how do we change our key to key 0? Well, luckily, there's an assembly macro called mode set, and we just change it to key 0. And then once we do that, to issue that macro, you must be APF authorized to issue that, right? So in Unix, if we use that extattr command, we can make it APF authorized. Now, what does that look like technically? Like, what does that look like in practice? So here is what it looks like in assembly. Any questions? We can move on? Great. So really, this is the command here. Oh, that's great. The boxes on my laptop worked, so this is their laptop problem. So mode set key 0, that's the command. If the program will abend if it's not APF authorized here, so that means crash, right? So once it gets past that, you're golden. The next thing we do is we issue what's called a rack route. So this is going to build that new ACEE for us. And if you'll see there where it says user ID equals user len, well, that's actually down here where we have the user ID that we want to assume the identity of. Okay, so all we do is we write this program up, then we put it into a file in Unix. We assemble it. So if you've ever used the assembler on Linux, it's the same thing, right? This very similar commands. Then we link it, right? Because we have to link it. And then we make it APF authorized. Okay? So that's it. That's all the steps you have to take. And then here's a demo that we put together. It's going to show Chad taking over my account, right? So he's trying to access a file. He's unable to access that file. He's going to run his APF authorized program. And now you can see he's become Phil, right? He's become my user ID. And now he's able to cat that file. It's a file I wrote for him especially because he is the coolest. I did not write that. This is a 100% Chad demo. All right. Next picture of Chad. Take Phil to a karaoke bar and get him to do Regulate. You won't be disappointed. You will be disappointed. I promise. Okay, let's look at the next one. Sudo root. I know it says sudo root. There's not really a concept of root users on the mainframe. Okay. So on the mainframe, we actually call it super user or UID 0. Okay. The problem is, on Linux, if you get root like UID 0, it's game over for that box, right? You can do anything you want. You can change anything you want. The world's your oyster. That's not really true on the mainframe. Yes, you have UID 0 in Unix, but that doesn't convey anything outside of Unix. Like when you log in, that address space that we talked about earlier in key 0, even though you sue up to root, it doesn't change your actual user and address space in the rest of the mainframe. So here's an example. So here I am. My user ID is Phil. I type the su command. Notice I don't have to provide a password. So I type the su command. Now I'm a different user, theoretically, right? But when I do the recf command lu, I'm still me. But that's fine. There's a billion ways around this. This is just one dumb example. I'm sure if you're creative enough, you can find 1,000 different ways to do this. But the easiest thing for us is just to add an SSH key for an admin. So, and that's really easy. So we pick Mark, of course, and we make the .ssh folder for him. We then make the authorized key file for him, make sure the permissions are good on that file, and then we put our public key in there, right? And that's what it looks like. Everything's fine, everything's good. And then we just SSH in as them, right, with our private key that we generated ourselves. And then we're logged in as Mark. And if you look at Mark, Mark is special operations. So it's game over again. So I don't know if you're noticing a trend, but we have, like, our two goals is either to get special operations or APF authorized. Those are the two things. All right, next one. The lucky among you might get to play craps with Phil later. Damn, I'm sad I'm missing that. Oh, thanks, Chad. Okay, next. This mount one. Okay, when you look at when you look at the mount points, if you've ever mounted an ISO in Linux, it's very similar, right? Think of it almost like volumes in a container, right? So you take the whole file system is based on data sets, right? And you mount those data sets into a location on the file system. That's all it is. Now, if we have update access to either of these two profiles, right? superuser.filesys.usermount or superuser.filesys.mount. What that means is we can mount a data set and preserve the APF bit and the setuid bits. If we have read access to either of those profiles, then those bits are ignored. But and if you saw in our output, we definitely did have access to superuser.filesys.usermount. So what we do is we create a payload on a mainframe we own, right? I have a mainframe at work. Chad has his own mainframe at his work. So we create a data set that that's going to be malicious. Then we create our programs. The ones you just saw, we can make them APF authorized in our own system, right? We can craft this payload. We unmount it. We package it up with some JCL. We transfer it to the target mainframe, and then we receive it and do all these things, and then we run our tools. So this is the JCL to mount that data set. It's very familiar to like the mount command, right? So we have, we're going to mount the hack the planet, and then we have a mount point that goes to /temp/hack the planet. And then when we look at the output, you can see here, this one maintained the set UID bit. So now we can sudo root, we'll get UID 0, bypass without having to do any of that fancy stuff, having access to bpx.superuser. And you notice there's programs here that are APF authorized. Even though we don't have the ability to do that on the target mainframe, because we could mount a file system, we could do that. Now from here, the demos are exactly the same as the other two demos, right? We can either modify people's home folders, or because we're APF authorized, become any user we want to become. Great. He's wanted to tell you that he grew up on a farm, and the tractors all ran on COBOL. I highly doubt that, but all right, let's talk about buffer overflows on the mainframe. You know that slide earlier with Ralph, and it said you can't do buffer overflows on the mainframe? That's a myth that has been debunked multiple times, and I gave a talk last year at Share, Share's being the mainframe industry conference, where someone in the audience was like telling me, you can't do what you're telling us you can do. And I'm like, guy, the whole talk is about mainframe buffer overflows, and I'm teaching you how to do it. And he still wouldn't believe, right? So there's still this myth that you can't overflow buffers on the mainframe. It is so false. Anyways, lots of programs in Unix are written in C. C is not a memory-safe programming language, okay? And so if you have a C program and there's a buffer overflowable variable, and it's APF authorized, now we can execute APF authorized code because of this program, right? How do we find APF authorized programs? Oh boy, this red box is way off. So how do we find them? We use the -exta. This is a find command. And you can just find and then -exta, that's extra attribute A. That will show us all the APF authorized programs that exist on that LPAR. This is just one screenshot. It kept going forever. Am I saying that all these are vulnerable? Probably not. Probably, a whole bunch of them are probably not vulnerable at all. But I know researchers who have found vulnerable programs that were APF authorized. Okay? Unfortunately, we have like 10 minutes left. Getting into the complexities of writing a ZOS buffer overflow would take hours of content to get you to understand it. Fortunately for everyone here, there is hours of content available to you to learn this on your own. Jake LaBelle gave a great talk at DEFCON 30 on how to find and exploit ZOS buffer overflows and explain the memory layout and all that stuff. Don't take a picture yet. There's like 2 more things to go through. Chad gave a talk. In fact, if he was here on stage, this would have been our 10-year anniversary giving co-talks. We gave a talk 10 years ago. And part of that talk, he explained how he could do buffer overflows in ZOS Unix. And Jake and I, DEFCON 30, we taught a class on mainframe buffer overflows. And that class is freely available. You go to, if there's a Docker container, you run it, and it walks you through step by step how to do a mainframe buffer overflow so that you can generate something that looks like this. Okay? Did anyone get their picture? I saw some people trying to take pictures. You want me to go back? Everyone's good? All right. So this is doing like the stuff we were talking about earlier, right? The rack routes and all that. So this is machine code that we're going to use to overflow the buffer. So that's shell code. We don't call it shell code, but it's shell code. All right, here we go. Here's the next one. He wanted me to say that Phil and I had a tradition of going to piano bar after every evil mainframe training. Ask him about the fish bowls. Be my guest. It's fine. Okay, let's talk about some honorable mentions that I see on pen tests. So remember how we mentioned that you can enhance your security by letting the ESM have like more security on top of the file system, right? I have been on systems where that was done improperly, and while it looked like I didn't have read access to some folders or files, I could read every single file on the entire ZOS Unix because it was not secured properly. This one's fun. There was a shell script in bin that was world writable. That was chmodded 777. So it was in /etc/profile. So every time someone logged in, it ran. So I just modified it a little bit, and then when a user that was special logged in, it then made my account special. This one is not really an exploit or anything like that, but this happened too many times. I want to let you know about it. Please don't make your logs that go to the SIM world readable or writable, because I've been on like 2 or 3 mainframes now where the staging folder in Unix and the files in that folder are world writable. Okay, so please don't do that. Last one is I was pen testing a mainframe. I couldn't access much in ZOS Unix, but they had a web app that had an LFI vulnerability, a local file include, and then I could read a whole bunch of files. So I was like, I could see where they were, but I couldn't read them, but the web app could. Now, I would be remiss if I didn't tell you how to prevent and detect these, right? I hate watching talks at DEF CON. It's like, oh my God, that's terrible. What do we do about it? Too bad. That's not what I'm here for. That is what I'm here for. I'm going to tell you how you prevent it and how you detect it. So first, prevention, right? Review your file permissions. You can just run a find command to find everything that's been chmodded 777, okay? Please check every single pen test I do, I have file permission findings. Please check your file permissions. Review and control access to these profiles in your ESM. They are the same profiles. Doesn't matter if you're on ACF2, top secret, RecF. Make sure access to these profiles is limited. In fact, I would argue no one needs to have this access unless it's a break glass account, right? Test your file permissions. Even though the file permissions look correct, there might be something in your ESM that's overriding those permissions. Okay, now let's talk about detection. Monitor, we say log, monitor your SMF messages. SMF is the logging facility for ZOS. Someone who's using bpx.superuser, so every time you type su, the operating system goes and says, hey, does this user have bpx.superuser? And then it says yes, right? Or it says no, right? If it says yes, you should probably be monitoring for that. Who's using it? Why are they using it? Same with the bpx.file attr.apf. No one should really have that. That should be something that you're installing updates or patches, but no one should just have that as a blanket access right. If someone is using it, it should be traceable back to a request or a ticket of some sort. And then obviously the mount commands, again, users shouldn't be mounting things as a super user. That should be all done by the operating system during startup, right? Like, no one should really have that access unless it's like a break glass situation. Detect large number of unauthorized attempts to access files. You'll understand how, like, it will log every failure when I run my own VS enum script. It's looking for files, and it'll tell you, like, access denied, access denied. Those all get logged somewhere, right? No one has ever come to me after a pen test and be like, hey, did you try to access, like, 30,000 files? Never, because no one's monitoring it. Detect multiple, obviously, look, if you're trying to see someone do connections out to AWS on your like firewalls and whatnot from the mainframe, that's probably a good indicator of compromise, right? Something to check for. Because the mainframe should have very well understood and well-known patterns of connectivity. There should be nothing exciting happening there. And then we're going to talk about the Unix file system auditing. This is like very unique to ZOS Unix. So when we run ZOS Unix, and when we're running ZOS Unix, and we issue ls with a capital W, we get this new column here, right? And this column is the audit column, right? That's what's happening here. So let's take a closer look. It's split up into two parts. The first part is user controlled. So if you have read, write, execute access to that file, you can modify those settings. The other three are admin controlled. So if an admin wants to set, so you could set it as like, hey, I don't want any audit records for this file, but your admin could set something that says, hey, I want to know anytime someone changes that file, right? And you as the user you cannot change it back. This is the default. So F for fail, and then no admin control. This is the default for every file created in ZOS Unix. If you list any file, that's the default. And the way it's broken down is very Unixy, read, write, execute. So if I try to read the file and it fails, it's going to write an SMF record. If I try to write the file and it fails, it's going to write. And if I try to execute, it's going to do that. Now, much like you can ch modify, you can ch audit a file. And so you use the ch audit command. And what we're going to do is we're going to say, I want success and failures. And now when we run that same command, you can see now they say all. So now I have all, anytime someone accesses that file, anytime someone writes that file. Now, this is a little extreme. Don't do this for every file, but you should know what files are critical to your mainframe. And you should know, hey, if someone makes a change to this file, we want to know about it, right? Things in /, et cetera, probably a good idea to know who's mucking around in /, et cetera, right? Okay, so with that, we're nearing the end of the presentation. I have to do some shout outs to, because I'm up here because of the efforts of a lot of other people. So first, I want to say thank you to DEFCON for having me come here. I really appreciate you all. The mainframe hacker community, when Chad and I started doing this, the mainframe hacker community was 2 people, Chad and I, okay? Over time, that has grown. The third member was Henry, Wizard of Zos. And over time, that has grown, so now there's like a good 24 of us, and we chat, and we all know each other, and we share ideas and whatnot. So I have huge thanks for them. The Moshix Discord. So if you're not a mainframe person and you're like, oh man, this is interesting, go watch Moshix's videos. Go to the Discord. It's super welcoming. It's not very. Do not go to mainframe forums. It is the most adversarial place on earth. Go to the Moshix Discord. It's super chill. Everyone's there to help. The mainframe cybersecurity community, I went to Share being the mainframe industry conference, and I was so nervous the first time because I thought they hated me and all these things. In fact, a major vendor threatened to pull out if I spoke at that conference kind of thing. But the mainframe cybersecurity community at that conference is the most welcoming and amazing community there. So huge shout out to them. And I do want to thank my co-speaker, Chad, for helping me out with this talk. And I do really wish he was here. If you want to contact, if you want to reach out to me in any capacity, if you have questions, I'm always interested if people have ideas or questions. I will take any pull request within reason. So if you want to look at my code, it's not good, but it works, right? So if you want to take a look and reach out to me, that's totally fine. And I'm going to leave the talk with the last quote from Chad. So remember when I said there were 2 members to the Mainframe Hacker Society, and then Wizard of Zos joined us? That's Wizard of Zos in the middle there. So that's, it's a tight-knit group of people. So this is what he wrote for me. I'm going to try to get through it because it's a little long, and I love it. So dear Phil, in all seriousness, I am really sad I couldn't be here, even though I know that you absolutely kicked ass, and you do not need me here to do so. You've been one of my best friends and partners in crime for a decade. I would not be here where I am without your friendship and knowledge and willingness to put up with my shit. I cannot wait to see what the next decade of hacking the Gibson with you brings. And with that, I want to thank everyone for being here, and that's the end of my talk. Yeah, I heard that.
Good morning, DEFCON. It is Sunday. It is 11 o'clock. You need to be more awake than that. Good morning, DEFCON. Thank you. So we are about to hear from Enzo, but it is his very first talk here at DEFCON. So because it is 11 in the morning, it's certainly 5 o'clock somewhere. So we are going to shot the noob. So grab your drink. Trash. You are good to go. I'm going to give you 10 minutes, 5 minutes, no time.
All right. So everyone, with that done, we have no time to waste and a lot of ground to cover. This is Journey to the Center of the PSTN. I'm Enzo D'Amato, and first a little bit about me. So I got into computing when I was very young, got a bunch of servers, turned them into this, then got one of these, and put my servers in a professional data center. After doing that, I started looking for the next big challenge. I mean, after getting an ASN, you gotta find something new to do. And for me, the answer was telephones. I wanted to figure out how the phone network worked, how I could become a part of it, and some interesting and unique exploits that you could do from the inside of the phone network. And this talk will take you through all of that, how you can become your own Ma Bell. This talk, however, is not legal advice. It is not a comprehensive course on voice network design. It is not a guide to the regulations in your state. We're going to be covering licensing later on, and just remember to always check everything with what the actual rules are for your state, not just the generic nationwide rules. This is also not going to be PBX hacking. A lot of people have done that, and that's sort of overplayed. We're going to be doing everything from the carrier side. So with that in mind, what is the publicly switched telephone network? The PSTN is essentially any phone that allows you to call another phone using a standard US phone number. Some people define the PSTN as only phones that are connected over the traditional TDM network rather than phones that are connected over VoIP. However, in my opinion, there's no difference as long as the number is accessible from a standard telephone, so we're just going to say the PSTN is everything. And with that in mind, what is a phone company? In this case, a phone company, when I say I started a phone company and I run a phone company, I mean a real phone company that owns its own numbering resources in the same way an ISP that has its own ASN owns its own IPv4 resources. You're not just reselling, you're not just buying from a generic sub-trunk provider, and slapping a PBX on top of it. You're actually the carrier of record, you're managing the routing for those entities. A real phone company also files its own FCC 499, so it files federal taxes for phone companies, and it's interconnected with other carriers. Again, manages its own routing. It doesn't just send everything through whatever its upstream is. And why should you care about this? Well, the answer is that we, in the hacker community, used to love phones. This was how the community started. DEFCON groups are still labeled by area code, and phreaking was everything. But then everyone sort of lost interest right as the network started to get interesting. Because in 1996, you, for the first time, were allowed to become a competitor to Ma Bell for local exchange service, which means you could become a legit phreak. You didn't have to do it in secret anymore. And with that, the amount of stuff on the network, and therefore the interesting bits of the network, got way larger and way more interesting. So we're going to be looking at all of those new interesting bits of the network. Unfortunately, we do have to cover first a bit of history and a bit of terminology for those who are new to phreaking and new to phones. In the beginning, there was AT&T. AT&T was an amalgam of one major long-distance company and then a local Bell operating company in each region. The long-distance company did long-distance, and the local companies provided dial tone and local calls. However, this would break apart in 1984, which created 9 separate RBOCs, or regional Bell operating companies, in each region of the United States, and one IXC, or inter-exchange carrier, that was the AT&T long-distance entity, that was subject to competition for the first time. MCI, Sprint, the other long-distance carriers, if you remember dial-around codes. And this is sort of a graph of how things broke apart and then merged back together. As you can see, there are 3 major phone companies, all of which own their own long-distance branch, and all of which also own a significant chunk of the U.S. geography for phones. The only difference now is that Quest is now level 3, but these companies are the RBOC successors, what happened after the RBOCs got broken up. And an interesting note here is looking at what an actual local call is. Because when we say we have local exchange carriers and inter-exchange carriers, what is what? And this up on the screen here is a map of all of the LATAs, or local access and transport areas in the United States. Each LATA is the specific territory of one of the RBOCs, and any calls within the LATA are handled by that RBOC. Any calls external to the LATA are handled by an IXC. And within a specific LATA, we also have a number of numbering plan areas or area codes and rate centers. With calls within a rate center are always truly local. So, always truly local, meaning that they are not billed per minute. They're either billed not at all or per call. And usually there'll be an arbitrary boundary between that rate center and a couple of the other adjoining rate centers that will be included in that local calling scope. This is defined in the state tariff for the RBOC, and it is highly arbitrary. Unlike the LATAs, there's no federal standard for how big a rate center is supposed to be, what it includes, and sort of what the rules are for those. So you're going to have to check, for your specific rate center to see what counts as local for it. And therefore, we can sort of put together a taxonomy. We've got local calls that are always handled by the local exchange carrier and therefore governed by the State Public Utilities Commission as a local utility, and they're usually unmetered. And then we've got true long-distance calls, which are governed by the FCC under the Braille system breakup and handled by an IXC. However, then you've got a bunch of weird niche categories. So intra-LATA and intra-state calls are what are known as local long-distance, or long-distance calls handled by the local exchange carrier, or the baby bell. And then you also have inter-LATA and intra-state calls, which are counterintuitively more expensive than interstate long-distance calls because they're governed by the State Public Utilities Commission, and therefore, since the State Public Utilities Commission is a less strong regulator, those calls are more expensive because they can get away with charging more. And finally, you have a very weird category that usually only exists in the large flat plain states of interstate inter-LATA calls that are governed by the FCC, I think, and handled by the local exchange carrier. These basically only exist on paper, but this just goes to show you the weirdness and the state of the number of exceptions and oddities that exist in the phone network. When you have a bunch of categories that are created by successive regulations being layered on top of each other, you get these sort of weird categories. And this only is going to expand and create a bunch of interesting opportunities for us later. However, the real big change wouldn't come with the Bell breakup, but rather with the Telecom Act of 1996. This enabled competition for the local exchange carriers. These new entities, known as CLECs, were any local exchange carriers certified after 1996. It normalized wireless regulation and created the modern cell phone industry by allowing cell carriers to be treated as co-equal carriers to the LECs instead of just as basically almost as resellers that subtended off of them. And it also critically required the incumbent LECs, meaning the RBOCs, to interconnect their networks at any technically feasible point, offer services for resale, and to do all of this on non-discriminatory terms expressed in a publicly filed interconnection agreement. These responsibilities are known as collectively as 251, 252 interconnection. Together with the provision allowing for CLECs, that has been what has allowed the telephone network to really transform itself over the past couple of years. It's how we got VoIP, it's how we got new carriers, and it's how I was able to become a phone company at the age of 19. Later on, we would see a new category of sort of a half CLEC certification created for VoIP-only carriers. This, known as an IPES, allowed those VoIP carriers to get numbering resources issued directly to them, but still required them to go through an IPES entity, go through a CLEC entity as their sort of parent company. The ILEC entity would manage the routing on their behalf. So sort of a half CLEC that doesn't have interconnection. So now let's get into how the PSTN actually works and how those calls are going to flow through the network. So here we can see an example of a modern LATA ecosystem as it exists currently. Each different company is represented by a different colored box. And as you can see, a call from an ILEC to a CLEC is going to go through obviously the ILEX network, but it's also going to go through a very special box that exists in every LATA, the ILEX Feature Group D tandem. The Feature Group D tandem acts almost like the default route for everything within that LATA. If two carriers don't have a connection to each other, they're supposed to always have an interconnection with that ILEX Feature Group D tandem as part of their interconnection agreement with that ILEC, which means that those calls can flow through that Feature Group D tandem to sort of reach where they need to go. Either on the ILEC or on another carrier that subtends that ILEC. They can use that sort of as almost like a tandem that they can both reach. If a call is long distance, however, it's going to get piped out over the long distance network and then all the way back into the Feature Group D tandem in the new LATA. As an example, this is an ILEC to ILEC call. Critically, the ILECs, because of the regulations, are not allowed to carry their own long distance traffic between LATAs. So they have to send that traffic over an IXC. However, CLECs are not subject to the same restriction. So in this example, two CLECs in different LATAs are able to send traffic directly to each other. In this case, over an IP trunk that they have. So CLECs can actually use IP trunks. They can use, VoIP to send calls between each other. So the internal routings on, CLEC to CLEC or CLEC to, mobile calls can actually be IP in some cases. Finally, you also have an example of a CLEC that connects directly to the inter-exchange carriers, receiving calls from them directly instead of sending them over the Feature Group D tandem. In this case, the CLEC basically acts as its own Feature Group D or access tandem for the numbers that it has, hanging off of an IXC's one directly. This allows us to put together some general rules for routing with the caveat that voice routing is very ad hoc. It's not particularly well defined like BGP routing is, where like a BGP router will always be able to use BGP to pick the best route to a given point. An ILEC will not be able to do this because an ILEC routing will not be able to see the entire picture of the network at one time. It won't be able to calculate a best path, so it has to go through basically a series of rules defined by the regulations and the information that it does have. These rules generally are as follows. If two carriers have a private IP interconnection between each other, that will be used by default. It's much cheaper, and everyone prefers to keep things on IP as much as possible. If the call is local, however, it will be sent over the local interconnection. Local calls have to go over the local interconnection. If you send them over long distance, they won't route properly. However, if a call is intra-LATA, it can either go over the Feature Group D tandem for that LATA, or it can go through an IXC who can then be responsible for basically delivering it back onto the Feature Group D tandem through their internal network. However, if a call is inter-LATA, it has to go over an IXC. It can't get sent through the Feature Group D tandem unless that Feature Group D tandem is basically being used just as a bridge to reach an IXC. We can now look at phone numbers. Everyone's familiar with the basic parts of a phone number, but there's a bit more to it. So obviously in area code, one or multiple will be assigned to a single numbering plan area. And when there are multiple assigned, that's called an overlay complex. However, we also have the next three digits, the CO code, are the most important for actually routing the call within the numbering plan area to the carrier that it's going to. So this was the original basic unit of phone number routing from the original days of direct dialing. And these were originally assigned to a single end office, like a single building, back when it was the Bell system. After the breakup, these started just being assigned to a single entity, so it's like a single, licensed local exchange carrier. However, even this was too inefficient. They were noticing that, especially with the rise of smaller CLECs, you'd have CLECs that were getting a CO code in every rate center and only using about 1,000 of those numbers, meaning that all of those blocks, potentially hundreds of thousands, if not millions of phone numbers, would only be 10% utilized or less. This was extremely inefficient, and therefore they created the number block pooling system. Instead of assigning people CO codes directly, instead a CO code would be broken up into its constituent thousands blocks, and these would be assigned to carriers, and we would route on these thousands blocks instead of routing on the full CO code. This allowed us to make much more efficient uses of our routing, but it wasn't adopted everywhere. It was required in major urban and metropolitan areas by the FCC. However, in more rural areas, it's optional, and again, you'll have to check with your state Public Utilities Commission to see what rate centers in your area are pooled. Most of you will know that if you change carriers, you'll be able to take your number with you. However, you may not know how this is implemented. The routing that I just displayed is fairly static. It's based on block, so if you move your number, how is that number going to be able to move with you? The answer to this is number portability, or porting. The porting allows you to take the number with you by adding a routing overlay, a query layer on top of that existing base routing structure. And the way this works is that each number gets an LRN in addition to its, normal appearance. And when that number is called, we hit a database for that outgoing call and we get back the LRN. We are guaranteed to know that the LRN will be a phone number, in a CO code owned by the destination carrier. So the destination carrier's CO code will point to that switch, and then we can route to that CO code, and we know that routing to the LRN CO code rather than the original dialed number will get that call to the switch where it actually lives rather than the carrier that initially owned that number. And then we can put all this together and actually figure out how routes are built. So an AOCN loads routes into birds. Birds then feeds a database called the LURG. The LURG is a pile of CSV files, a bit like several gigabytes worth of CSV files. And those CSV files form the routing information for the entire network. These CSV files are sent weekly to all of the carriers that are subscribed to the LURG, and then they use these CSV files to manually build routing entries on their switches, sometimes using scripts, especially if they're a larger carrier. And within the LURG entries, there'll be a bunch of codes known as silly codes. The silly codes identify each individual switch or routing entity on the network, and then these codes are then manually associated to either SS7 point codes, in the case of SS7 signaling, which is the most common, especially for legacy networks, or sometimes for VoIP signaling in the case that the two carriers have implemented VoIP between each other. This is a very manual process, obviously, and it takes, on average, 30 to 60 days for the network to update with a new full CO code, and about 14 days for a new thousands block. It's slow, very, very slow. And the reason for this is because, again, it's a very manual process. Those switches do not have the capability to communicate routing information to each other, so we have to maintain the routing information centrally. All of these different parts of the network are governed by separate regulatory bodies that you're going to have to interface with. So phone numbers are governed by NANPA, or the North American Numbering Plan Authority. Portability and number porting is governed by NPAC. Operating company numbers, or OCNs, which identify individual telcos, and individual telcos in a state, are governed by NECA. And then silly codes, the SS7 point codes themselves, the LURG, and IAC codes, and basically any other code that you'll need is controlled by a company called iConnective, which is basically allowed by the FCC to have a monopoly on routing information for the entire network. Billing is another interesting topic. In almost all cases, the calling party pays. It's not billed 95.5 like internet traffic is. It's strictly billed per minute based on the calling party paying, with each call counting as an additional billing counter. The calling customer pays the calling local exchange carrier. The calling local exchange carrier pays the IXC that they're using to route that call. The calling IXC pays the receiving IXC. The money flows along the call path from entity to entity. It's not end-to-end, it's hop by hop. And there are also a few special cases. The most prominent is 800 numbers, where the money basically flows in reverse. There are entities known as RESP orgs, or responsible organizations, which handle the toll-free routing, and they handle billing for that routing, and the billing passes from the called party back to the caller. 900 numbers and 500 numbers used to be special cases because they were premium numbers that were upcharged. However, these numbers don't exist anymore. The software to build them no longer exists, so they're not routable on the current phone network. Local calls are almost always unmetered, or if they are metered, they are pay per call, not pay per minute. So now, with all of that information, all of that details about the phone network, let's actually get to doing something interesting and useful with it. We'll start with access stimulation. So if you were listening during the segment where I was talking about phone number billing, you may have noticed that the calling party always pays. And since most people nowadays have an unlimited minutes plan on their phone, can you make money off of this? Having people just call you and collecting the money? And the answer is yes. Access stimulation has been one of the longest running legalized abuses of the process since the very early days of competitive local exchange carriers. And the process goes about like this. We have, you know, so all we have to do in order for this to work is to get people to call us. It is that simple, because the money will always flow along the calling path, and our carrier will pay us. So we just have to generate a volume of calls. So imagine it's 1996, and you need people to call you and sit on the line with you for a long period of time so you can make money. How are you going to do this? And the answer is dial-up. Dial-up in 96 was the golden ticket for this. There were many CLECs that were created specifically for the purpose of either being or serving dial-up ISPs. The dial-up calls were 100% inbound, and people sat on the line for hours. So they could just rack up the billing. They would sit on the line, and the dial-up ISP would, become a CLEC. Since they weren't serving real customers, they didn't have to run lines. They didn't have to get a fancy switch. They had almost no costs. They just had to connect their dial-up modems into the interconnection trunks that they were getting from the RBOC, and they could collect those inbound minutes and profit off of this. However, the FCC would kill it in 2001 with the ISP remand order. They would rule, and I still do not understand where they got this from, but they ruled that internet traffic is considered interstate because it's going to the internet rather than another person at a fixed location. I still don't know how the FCC came up with this ruling, but they basically did it so that they could seize control over the reciprocal compensation for those ISP calls, which had previously been a state issue. And then the FCC basically said, since this is interstate, we can set the rates for it. We say you get nothing. This doesn't count. ISP calls don't count. You can't get compensation for them. Later on, much later on, they would kill local compensation for local calls altogether. However, there was still another plan. All we have to do is get people to call us. So if dial-up isn't working, what are we going to do now? We're going to give people free stuff. FreeConferenceCall.com is one of the original people who pioneered this space, but there were a lot more. Basically, any music, chat line, conference site, anything that people would call into and use for long periods of time. And critically, during the period between 96 and when dial-up died, when the dial-up loophole died, people got unlimited long-distance packages where they could talk long distance for a long time or almost unlimited amount of time. We combine the free stuff with locating our numbers in the middle of nowhere so we can harvest higher per minute rates from them. We combine that with our unlimited plans, and we get a pile of money. We're talking millions upon millions of dollars back when this was running at its heyday, and we make AT&T extremely mad. This likely cost AT&T more in a month than all of the freaks of the 60s and 70s did the entire time they were operating. The scale of this was really astronomical, and it hit its peak during COVID, back when everyone was calling into conference call sites. However, this too would die. In 2011, the FCC finally closed the loophole and said that if you're doing a revenue share agreement with the person who's driving your inbound traffic, and you either have an over 3-to-1 in-out ratio or 100% year-on-year increase in inbound calls, you don't get access revenue. Unfortunately, there was still another loophole. In certain rural areas, there were specialized collector IXCs that basically pooled access to a bunch of rural co-ops. And collected that long-distance traffic, and they could bill for that. So we would put our access stimulation behind like 20 of these that still existed and have them bill it, because that was a loophole. The FCC would close that loophole. We would try again, and we would add an IPES company between the LEC and the high-volume endpoint, and now the LEC would bill the access minutes, and this was also a loophole. They only closed this one last year, and of course, people have moved on to something else. This, like I said, it's the longest running, basically free money glitch in the phone network. People have been using this for years. I'm sure people still continue to use it until they get rid of, until they get rid of per minute charging for long distance calls. And you may be wondering, why do you care about this? And if you've looked at your PBX logs, if you have SIP exposed, you may have noticed that there are a lot of people attempting to brute force your bots. Why? Why are people trying to brute force PBXs on the internet? How is that a profitable activity for them? And the answer is that this same principle that works for domestic calls also works for international calls, where the rates aren't, half a cent per minute, they're 50 cents a minute. And if someone is actually able to get into your PBX and you've got international dialing enabled, or hell, even if you've got domestic dialing enabled, they will run up a tremendous bill on your PBX until you figure out that you've been hacked and you close the loophole. It is a pretty big money attack, and it's the reason why everyone is always trying to brute force into your SIP servers. Now let's get on to another attack, something more traditionally freaky. Let's say we want to make robocalls and we don't want people to be able to identify that we're making them. The FCC quite recently added a new SIP header and mandated that all telecoms use it. This SIP header was the stir-shaken header. The stir-shaken header added a cryptographic signature to every call that contained certain critical details about the call and an attestation level. A, for a fully verified caller ID, where you assign the number to the user. B, for a verified customer, where you knew the customer but you didn't know that the number they were using was legit. And C, if you were just a gateway passing on a call to someone else. Passing on a call you got from another carrier onto someone else with no real information. But you may have noticed that if you have a phone, you've still been getting robocalls. This hasn't fixed anything, and the robocalls you're getting are still spoofed. This has fixed nothing. So how are the robocallers getting away from this? Because if you think about it, if you have a stir-shaken certificate for them, the police should just be able to roll up and arrest you. But this hasn't worked. And the answer to this is something that I'm calling the TDM shuffle. In a normal telephone arrangement, everyone will generally prefer IP trunks because they're faster, they're easier, they're cheaper. And most major carriers, especially people doing real volume, and the major cell companies have IP trunks between each other because they want to take advantage of those discounts. However, if we choose a provider that's, let's say, spammer friendly, that provider can choose where and how they're going to send out those calls. So they can choose to force those calls over the old school TDM network instead of the newer IP trunks. This means that those calls will lose their stir-shaken header once they go over TDM, because TDM doesn't support stir-shaken. So that header gets stripped out, and then eventually, once the call re-enters the IP network, a gateway node is going to see that it doesn't have a signature on it, and is going to slap a C attestation on it. If you're really lucky, you'll hit a misconfigured PSTN gateway that puts A attestation on everything. But either way, you've now gotten your spoofed caller ID to have a legitimate stir-shaken certificate on it, and the original destination of that call has been completely muggled, and no one knows where it came from. There are a bunch of approaches to this and ways that this can happen. The spammer can directly run TDM trunks into their boxes. More likely, the spammer will use a carrier that they know will support TDM. Sometimes the spammer can try and force the routings to force a call over a legacy pathway by calling between two providers that they know don't have trunks, that they know don't have IP trunks, even if both of the providers are legitimate. This can sometimes just be coincidental. A lot of phone companies, especially in rural areas, or just for whatever reason, are still TDM only. A large part of the network, I'd say about 40% of calls today are still hitting TDM at some point in the call chain. So, a lot of times that this stir-shaken header gets popped out. And with the weird routings, this can be very hard to diagnose and much harder to actually definitively prove to be malicious. There is a standard for TDM shaken. However, there is no date yet on a forced implementation. There's no even agreement on how the implementation would work. The FCC is working on it, but they're not done yet. And I'm sure the fact that the robocall carriers are harvesting millions of dollars in revenue for carrying these robocalls has absolutely nothing to do with the fact that we haven't gotten a fix for this yet. Yeah. Now, let's say we want to do something a bit less technical. We're not a carrier. We're just a jerk, and we want to blast people with spam. We can harvest a technique that will be familiar to anyone from the old days of email spamming. I call it snowshoe. But essentially, what we do is we get 20 shell companies, and each shell company signs up with 20 mom and pop or super tiny, VoIP providers that aren't doing good KYC, that aren't doing proper attestation. They're not doing caller ID filtering on their outbound calls, and all of these companies are going to get 5% of the overall spam volume. So the spammer might be having a tremendous spam pipe cranking out, tens of thousands of calls a day. Remember, the car warranty robocall, thing was one guy. That was one spam operation. That was one guy, and he had all of these accounts with a bunch of other people, and he was blasting these calls out and basically spreading them out. So even if any one of these, entities would get zapped by the government, there would be no way to really get the root guy because it was all shell companies. This was combined with the fact that a lot of these small carriers aren't doing KYC properly. They don't know who their end customer is. They're not stopping that customer from sending out stupid amounts of traffic for their profile size. They'd let a residential customer have 100,000 lines active, and that can become a real powerful attack vector. This is made even better by the fact that numbers are so cheap now. If numbers are 1 cent each, we're going to buy one per day per company and just switch them out. And the state attorney's general robocall report has noted that this is one of the big issues they're seeing, that caller ID filtering has become almost useless because spammers will never use the same caller ID for more than a couple of calls. And we can, of course, mix and match both of these techniques for maximum damage, spreading calls across piles of tiny, middle of nowhere in the country TDM carriers, all of which aren't doing KYC, all of which are muddling the call flow, and all of which can never be tracked back to us, especially when you consider that a lot of these carriers have 3 or more resellers and other entities in the chain, between customer and the actual entity in the LERG responsible for routing. And since only inbound carriers require licenses, none of these, high-volume VoIP carriers are regulated, so you can't take away their license. You can't kick them off the network. You've got a recipe for infinite robocalls with almost no mitigation. And this is just scratching the surface of, carrier-side VoIP abuse. Again, once you get your certification, the doors are open to you. You can do everything that you want pretty much legally. You've got local number portability abuse. You don't need a PIN for wireline ports. You can just make a fake LOA and steal someone's number. SS7 devices haven't been pen tested in, I think, ever. And that's not even considering just plain freaking, sending out calls with no ANI, sending out calls with a charge number set to someone you don't like because they get billed for it. Sending out, using your access as an AOCN to hijack number blocks and numbering resources. Vulnerabilities on 20-plus-year-old hardware like 5Es and DMS 100s that, again, have never been pen tested, but have a bunch of interfaces that may not be accessible to the public, but are certainly accessible to other telcos. You're basically only limited by your time and the imagination you're willing to put into this. It's like a new internet to play with. It's wonderful. Now, finally, hopefully you're all interested enough that we can discuss CLEC formation, the actual process to become a phone company. So let's do this, and let's do this quickly. So, first thing you're going to do is you're going to need to get certification. So then establish interconnection with another phone company so your calls will route, set up a switch, get your numbers, and then handle taxes. So there are a bunch of different types of certification. I'll let you read this slide later, it's on the server. But the key ones you need to understand, the ILECs are existing phone companies before 96. There are no new ones, you either have to buy one or merge into it. CLECs are new wireline companies, and cell companies are wireless companies, and IPEs are IP only. In terms of picking which one you want to get, if you can afford it and you don't plan to be doing like wholesale minutes because wireless carriers have to sell wireless, wireless is by far the easiest type. It's included with your wireless certification, so if you can track down any common carrier wireless certification, you're basically good to go. If you don't need interconnection agreements, you can get an IPES. However, it's nationwide, it has minimal ongoing paperwork. However, the FCC is slow and expensive to deal with, and again, you don't get to do interconnection agreements, so you're basically completely shut out of TDM. If you want maximum power, like you want the full set of certifications, you want to be, as Ma-Bell as you can be, you want to get a CLEC certification. However, the downside is that these are a lot of paperwork. You have to get one for each state you want to operate in, so you have to file paperwork in each state, and you need to file ongoing reports in each state. It's also a tax headache, because again, you have to pay taxes in each state. However, the application process for all of these, again, except mobile, is fairly simple. You file with the State Public Utilities Commission. You need some financial information, balance sheets and income statements, resume for your key executives and key personnel, descriptions of the service area that you want to serve and the services to be offered. This can be the whole state and everything. Just write something that sounds good for those categories. And a brief description of what equipment you want to put together. Again, the people at the PUC aren't really tech experts. They just want to have some idea of what you're going to be setting up. Then be prepared to wait about 30 to 90 days. In terms of getting approved, The best advice I can give you is to read the Public Utilities Commission docket. Every application that has ever been filed is public, and it's in there. You can read the applications that got approved, and more importantly, you can read the ones that didn't. You do what's in the good ones, you don't do what's in the not good ones. Download one that got approved quickly by a major carrier and just modify it to suit your needs. Generally, however, having a team is better. Hacking is a social activity, especially phone hacking. The more people you have on it, the more years of experience you're able to show, the better. This goes doubly well if you have actual telecom experience, but this isn't a necessity. Just have some idea of what you're doing. The biggest and most important thing is you can't have a criminal record or judgments, especially for fraud or consumer, consumer abuses. I don't know about other stuff, but I know that basically if you got convicted for defrauding people, they're never going to give you a license for obvious reasons. You also need some amount of money. The actual amount varies from 0 in liberal states, or not liberal as in politically liberal, liberal as in liberal in giving out licenses, to a fairly decent chunk in other states that require you to have a specific amount of equity or a specific balance. Again, check your state's website and read your state's laws. Read the laws. It will tell you what needs to be in the application. Make sure you put that stuff in there. And don't be afraid to call. Generally, the Public Utilities Commissions are more friendly than you might think. You'll have to, shop around a bit to get to the right person. But generally, once you get to the right guy, they'll be able to help. It's not as hard as it used to be. In the 90s, it was very difficult to get approved. Now, it's almost deregulated, so you just have to do a box-ticking exercise almost. Once you've got your certification, you need to get interconnection. There are two kinds: local, for where your numbers live, and long distance or feature group D for everything else. Inbound calls are hard, outbound calls are fairly easy, because for outbound you just use a normal SIP trunk for everything that's not local. The first step is to pick a LATA and a rate center that you're going to be getting numbering resources in. You have to pick the geographic location in the rate center in order to figure out what kind of interconnection you need and where you're going to grab it from. Local interconnection is the harder of the two. You need to find that you're going to need to get an ICA in the area where you want to get numbers. In the rate center where your numbers are going to live. For RBox, this process is fairly standardized. If inflexible, you're going to send them an email. They're going to send you an information request form and credit application, and then a draft interconnection agreement that's part of their standardized template. You're going to fill out the draft ICA and send it back to them, and you're done in about a month. For a smaller ILEC, the process is a lot more variable because they almost certainly won't know what you're talking about. You're going to have to go through multiple rounds of people until you either get their regulatory guy or their whoever is responsible for that at their company, and you might have to send them a draft ICA because they might not have one on file. But the upshot to this is that even though it's harder to deal with them, they are more willing to negotiate and more flexible. So if you need something that the RBOC doesn't want to give you, they'll be more helpful. If you want to deal with TDM, you've got a few difficulties. So firstly, the actual media part of TDM is pretty easy. Cheap T1 media gateways are everywhere. However, SS7 is a real killer. If you have to deal with it, you're basically going to have to develop a custom platform because it's not supported on anything. However, you can order MF trunks still in a lot of parts of the country, so you can use MF to avoid this. There are also interconnect companies that make the process easier. Peerless, Intelliquent, WideVoice, the big three. However, there are a lot more. These companies basically provide you a TDM and IP translation service. However convenient this may be, it also is an added cost per minute and sometimes per number. Check with whatever provider you're going to deal with. But this avoids having to pay for either a fiber midpoint splice or leased facilities from the ILEC. This isn't that bad in terms of actually ordering real TDM from the ILEC if you're close to them, if you're in the same LATA, if you're in their service territory. However, if you're outside of their service territory, those rates are no longer regulated and therefore are obscenely expensive. We're talking tens of thousands of dollars for a single T1 if you need to run it like between states or something. So again, your mileage may vary. If you're staying local, you might be able to just deal with the RBOC directly. If you're not, you might have to do something different. Long distance interconnection, thankfully, is a hell of a lot easier. You can just get an ICA with your RBOC. If you have an ICA with your RBOC and you're doing TDM, you can just do long distance through them. Otherwise, you're going to want to look for an access homing tandem service. This is either cheap or free, again, depending on who you deal with. If you're doing if you're doing decent volume, you can even get some of that access revenue that we were talking about before. In either way, this is easier to get because there's no incentive for long-distance companies to protect their brand or their territory. It's a profit center for them to be selling, interconnection because they're getting, a fraction of that per minute revenue. Switch building is where you really get to exercise your creativity. A couple of the major SIP platforms, I have their logos up, but you're going to pick one or multiple of these and put something together. Generally, you're going to need a session border controller or a gateway signaling element to deal with SIP and load balancing and that sort of thing, and then some sort of media element to do codec translation, to do NAT traversal, that sort of thing. This is where you can really show your creativity and make your voice service unique. There's a ton of flexibility you can show here, but it is a bit of a larger project because you're going to have to develop something. Again, this is also sort of what you want to do. You can get away with a single asterisk box if you just want to be tiny and serve yourself, but if you want something production ready, you're going to need to do more. A couple key notes here. IMS is the standard for LTE. It's confusing, difficult, and generally a nightmare to work with, but you do need it if you want to deal with phones or if you want to follow the technical standard for residential VoIP services, but no one really uses it if they don't have to. And finally, commercial switches, your old stuff, your 5Es, your DMS 100s, or your meta switches and ribbons if you want to buy modern stuff, are very expensive and less customizable, but rock solid reliability. We're talking 5 nines for a single box and have everything you're going to need out of the box. So if you're willing to pay out of pocket for them, they might be worth it. There are a couple of pitfalls with switches. Biggest one is LEC style routing. So local and intralattic calls, you're going to have to pick those out and make sure they go over the correct trunks. You may have to support equal access depending on whether someone asks you to and the regulations in your state. Again, check your local laws. And you may have to deal with TDM and SS7 as we were talking about before. So you may need media gateways. You may need other gateway type elements. You may need an SS7 signaling gateway. Billing can be a real nightmare if you want to do proper telco style billing where you're billing local calls separately, you're billing per minute, you're billing cabs or access revenue for inbound. You're also going to have to deal with high availability and failover if you want to meet certain state standards for time, for uptime. A lot of states have a standard of 4 nines of uptime for your switches, so you may have to make sure you're suitably reliable and not just running on one box. You may also want to go multi-site, especially if you're going to be pumping a lot of traffic through one central instance. There are issues for how to do this, clustering and that sort of thing. VoIP is not particularly easy to cluster like websites. Once you've got your switch set up, you're on the home stretch. Now all you need to do is follow for your numbering resources. You're going to go to NAMPA, or the North American Numbering Plan Authority. You're going to send them your OCN. You're going to send them your long distance interconnection details, and you're going to send them your SILI code for your switch. Then you're going to wait 45 to 90 days to get your central office code, or a bit less if you're just getting a thousands block. Once you're approved by NAMPA, you're going to get an AOCN to put the numbers into birds and set up the routing records. You're going to talk to them about how you want to get your routing set up, and then you're going to input your numbers into NPAC so people can port them. After you're all set up and all fully online, you're going to submit Part 4 with NAMPA, and if your numbers are pooled, you'll also have to send in a PSTN confirmation to say, basically attest that you've fully built out the block. And then you're done. You are now an official phone company with your own numbering resources built out and with your own interconnection set up and routed. We're going to finally have a few concluding notes and hopefully get that done before we run out of time. So firstly, if you're a phone company, or hell, even if you have an internet-connected PBX, monitor your call and SIP logs, set alerts for unexpected usage, especially for weird international destinations. Lock down those weird international destinations. If you're a normal company, why are your employees calling Uganda? They probably shouldn't. Nothing wrong with Uganda, just they charge like 50 cents a minute for a call. So you want to make sure that's not happening if it doesn't have to be. DID rotation or people swapping out phone numbers if you're a carrier is not normal and is almost a certain sign that that person is using your service to send spam calls. You're going to want to monitor your customers too. Know the real person behind every company, know who's making your calls, know who you're dealing with, and set limits on your switches to match that. If a customer says they're home, they don't need to be making 40 calls at the same time. If a customer says they're a large business, you should expect them to have, not be switching out their numbers every 2 days because that's not normal for anyone. And never give out people the ability to swap out their caller ID and basically supply what the caller ID is going to be unless you absolutely have to. It's the #1 way that spammers are able to abuse phone services. In terms of public policy, if we have any feds in the room, require ILECs to support IP interconnection. This would solve a huge chunk of our issues for the TDM shuffle and the evasion of STIR/SHAKEN. And it would also, at the very least, get the FCC moving on mandating out-of-band STIR/SHAKEN support. This would be a big thing for fixing a lot of our, a lot of those problems. End-user SHAKEN might also be a good idea. If you force the end-user PBX to sign the call rather than the, calling carrier, this would allow us to set up proper, black hole lists for PBX for people who, calls are frequently associated with spam. And it would allow us to track the call directly back to the originator rather than their carrier. And we also need better enforcement against criminal telcos. I have no proof of this, but I would estimate that 50+% of all robocalls right now come from less than 10 carriers who make this a market for them. These guys need to be kicked off the network because they're the source of all the spam, basically. Finally, I will ask you nicely, if any of you have equipment that you don't need, please, like if you have 5Es, if you have old step-by-step stuff, even if you have like mainframe gear, I've also got the Z 114. If you have anything, or if you just are an ISP, an IXE, a LEC, an ASN, you want to peer with me, I'll connect with anyone, and I will give any unloved equipment a new home. Finally, I'll like to give a thanks first to DEFCON for inviting me here to speak. Second to Livewire Telecom and my friend Dylan Cruz, who knows far more about TDM and the old phone network than I ever will and has been a tremendous help in this. Wide Voice, who is my future Group D carrier, and I have nothing but good things to say about their service. And finally, YKC Communications in Ganado, Texas, who did not have a choice when I sent them an interconnection request, but was still a good sport about cooperating. So thanks for following the law and being a good sport, I guess. And finally, call me. This is my information. I love talking about phone stuff with people, and I have no one to talk about it with. Please reach out. I will talk your ear off about any of this stuff. I love to talk to you. I love to talk about phones. And I think we're done with 1 minute to spare.
go. Yeah, and the lights come up. That's cool, right? It is bright. Hey, everybody. How's it going? Yeah, right. It's Sunday. You're all awake. That was great. Hey, everybody. How's it going? Yeah. Thank you. All right. Welcome to Track 2 Noon. We're going to have a talk here in a minute. It is Quentin and Will. And guess what? It is their first time presenting at DEFCON. And so, what does that mean? Shot the noob. So they have chosen, against all odds, to do Jägermeister, because we were all out of Malort. So with that, I will hand you that. And we'll do a cheers. Cheers, 3, 2, 1. Excellent. That's bad. Yeah, he's like, that's bad. Like, yes, it is indeed. It is indeed bad. So anyway, you all ready?
Yeah, we are.
Without further ado, Quentin and Will are going to wow you for the next 45 minutes. So let's give it up for them.
Thank you. Hi, everyone. Welcome to our talk, Turning Your Active Directory into the Attacker C2. Short as not that bad. Today, we'll talk about group policy, object enumeration, and exploitation. Let's first introduce ourselves. My name is Wilfried. I'm with my colleague Quentin, or Quentin in French. We do pen tests and red team at Synactive, and this is the first time for us at DEFCON. So let's start by a quick introduction. During an assessment, one of our colleagues said, well, yeah, we have an account that can modify a GPO that applies to domain controllers, but let us check for the ADCS first. So they enumerate ADCS, they find out they can exploit ESC4, which is a privilege escalation. They exploited it successfully, but at the end, they got detected. So now we always mess up with them, like next time, maybe don't go straight for ADCS and look at GPO. So this is why we are talking about GPO today. Group policy object attack vectors may just be the ugly ducklings of AD exploitation. Why? Maybe it's not well known, maybe it's too risky to exploit, because you can mess up Active Directory. Maybe there's not enough tooling. So we think it's a shame because attackers don't have such concern. And also GPO exploitation can be quite powerful because you can manage a lot of things into the Active Directory. So today we're going to give you a brief recap on how GPO works, how they are implemented, and we will list 4 tools that will show that we can enumerate them and also exploit them with different kind of parts. Okay, so let's start by explaining group policy objects. A GPO is a collection of misconfiguration that applies to AD objects. It's a core feature of Active Directory. It deals with device and identity management. And a GPO can define user settings and computer settings. I'll get into the details of that later. When you want to configure GPOs, you can open the Group Policy Management console. And GPO are not applied directly to user and computers, but most of the time to organizational units. They can be also applied to different objects such as sites or domains, but is less common. Something important to mention is like when you define settings through GPOs, by default GPO will inherit from the parent container. For instance, here, the default domain policy will apply to all child containers, all child organizational units, such as, for instance, here, workstation, servers, and so on. The implementation of GPO in Active Directory is a bit specific. They are basically made of 2 components. The first one will be the group policy container, which is an LDAP object. You will find GPO metadata, name, description, version, and so on. I will give some specific details after. You will also find the group policy template, which is an SMB share that will contain the GPO files that describe the configuration that will be applied by the clients. So what you have to remember is basically you have 2 components, the LDAP parts and the SMB parts, as are tied together by a specific unique identifier, the GUID. And basically, the LDAP part say where the GPO applies, and the SMB part say, OK, the GPO does these specific settings. OK, so let's try to go into the details of the first part, everything regarding the LDAP. There are some noteworthy LDAP attributes, such as on GPC objects, the GPC file sys path. It will indicate where the UNC path of the GPT, so the SMB part, where the GPO file located. You also have more attributes such as flags that will say the status of the user or computer configuration. It might be enable or disable. I will move on that later. You also have specific LDAP attributes on organizational units. For instance, the GP link, it will say if the GPO is linked to this organizational unit. It can also be enforced. And you have also options such as inheritance. And the other part, the SMB part, was the group policy template. So in the SMB share, you have multiple configuration files, such as group.xml, resti.xml, and so on, when you can specify those settings. If I take a quick example, on the bottom, you say groups.xml, which is where you can assign group assignments. Here we can see that the user Jack is added to the remote desktop user group. OK, so this is the basics. So now let's go into the details of the attributes. First, we'll talk about inheritance on organizational units. I mentioned previously that by default, GPO will be inherited on the child containers. What you can do is you can avoid this by blocking inheritance. And when you go on the management console, right-click on the workstation, on the organizational units, you can block inheritance. And what's the change? On the LDAP, you have the GP option that will switch from 0 to 1, and it will be 1 if inheritance is blocked. And when you do that, any parent GPO will not apply to the specific organizational units. We also have the link attributes. So GPO are linked to organizational unit, like I mentioned earlier, and this is done by the GP link attribute. You will find in the specific attribute the command name of the GPO, and at the end you will find an integer that will describe the link status. This integer may vary from 0 to 3, and it will say if the GPO is linked, enforced, and so on. And if the GPO, for instance, is enforced, it will ignore the inheritance status. Here we have the table that said the configuration. Most of the time you will find out that the integer value will be 0, but we can also see enforced GPO, so we'll find the integer value of 2. Move on to other attributes. Now it's related to GPOs. So I mentioned earlier that GPO can apply to user or computer configuration, and you can change it with the specific flags. So you can enable everything, which is the default. You can also choose to apply only computer or user settings, and you can also choose to disable everything. And what's going on behind the scene is we have a specific attribute, again, on the GPO object, which is called the flags, and we have an integer that will describe which component is enabled. So the integer, by default, the integer value will be 0, so basically computer and user configuration are both applied, but we can see sometimes it's, for instance, if the integer value is 1, only computer settings are applied. Last part regarding GPO implementation is we have, by default, the computers update their GPO. They're doing a background update every 90 minutes with a random offset from 0 to 30 minutes. This setting can be changed. On each GPO, you can change the settings and put the value of 0. And the documentation, if the value is 0, it will try to update the GPO every 7 seconds. I would not recommend to update your GPO every 7 seconds, but it's technically possible. And so another thing to mention is not all policies are proceeded. For instance, software installation will be only applied when the computer starts, or there are also specific GPO that are triggered when the user logs on the computer. So now how the computers update its GPOs. So first, it interacts with the domain controller, querying for the LDAP for specific attributes to know what are the GPO tied to the specific computers. It queries the attributes such as GP link or GP option that I mentioned earlier. And now the computer have a list of which GPO applies. Then it queries the LDAP again for more information, such as GP file syspath. So now the computers know where the files are located, where the SMB share. By default, it will be on the domain controllers in the sysvol share. It also retrieves all the information such as flag, is computer or user or computer configuration are enabled or not. And now, because it has all information regarding the LDAP, it initiates the SMB connection, and it retrieves all the file and applies the GPO. OK, so this was how GPO works. There's also a few other attributes that we don't have time to talk about, but it's not the main important one. So now we want to present you a tool that we developed when we want to enumerate GPOs and also doing like a stealthy way. We find out that during assessment, GPO enumeration is quite useful. It reveals valuable insights into the security posture of the system. And most of the time, we will see interesting stuff like group membership or addition, privilege assignment, registry modification, and so on. So it's quite interesting from an offensive perspective, and we go into the detail of each one. The first one will be, the most common one will be group memberships. Group memberships are frequently defined through GPO. Information that can prove crucial for lateral movement. For instance, I want to perform lateral movements, but I have a specific account. I don't want to try this specific account on every computer. It's quite noisy. I don't want to perform wide range scans, such as using netexec on large ranges. So by enumerating this through GPO, I know exactly where this specific user has administrative privilege rights or where it can do on specific computers. So I have a better understanding of group assignments. So let's do an example. Here, I'm calling the LDAP with a tool that is called LDIP, and I'll try to enumerate all the GPO. The first one is called Allow LGP. This is quite interesting for us because I want to perform lateral movement. And this is also something that we already seen during our assessment. So I'm interested in for this specific one. I'm looking at this specific unique ID identifier, which starts with 008. And then I go to the domain controller on the sysvol share, and I try to retrieve all the files dedicated to this specific GPO. And within those files, I find out there's a group.xml file that says basically the group domain user is added to the remote desktop user group. So I know this GPO is adding domain user to remote desktop. Now I need to find out where, on which computer. So like I mentioned earlier, by default GPO, most of the time GPO are linked to organizational units. So again, I try to enumerate all the organizational units, and I can see here that my GPO Allow LGP is tied to workstation organizational units. Next step is to find out which computer is within this organizational unit, and here we have the wks01corp.com. So now if I type everything together, I can know that the domain user group can RGP on the workstation1corp.com. So now I can move laterally easily without doing any noise. I want to be stealthy. So it's better to enumerate GPOs. What you can do also is privilege assignments. You can assign interesting privilege through GPO. For instance, you can assign the SE debug privilege, which allows us to debug any processes that you do not own, and it can be a free privilege escalation. We found out this is relatively uncommon, but still possible. But in reality, it happens. Here we have a practical example that the SETCB privilege has been assigned to any user on the machine. And basically, it's a free privilege escalation. With this specific privilege, you can add arbitrary groups to your token, such as administrator, and compromise the computer. What we see most of the time will be connection restriction. When you don't want your domain admin to connect anywhere in order to reduce the risk of credential exposure, you can perform connection restriction through GPOs, and basically they will deny access to specific computers. So it mitigates privilege escalation and try to preserve the tiering model. So when you're performing this kind of enumeration, you know, for instance, that domain admin will never connect to specific workstation or specific machine tied to organizational unit. So there's no point to go there and waiting for domain admin. You can also perform registry modification through GPOs. legacy name resolution protocols such as LMNR, MDNS, and BNS are relatively good exploitation vectors. It has been exploited since a long time with tools such as Responder, and administrators disable those protocols through GPOs. Here, we can see that the MDNS protocol has been disabled through GPOs, so by doing this kind of reconnaissance, I know that there's no point to exploit it on those specific machines. So it helps me to choose a relevant attack. Through GPO, you can also gather more information. For instance, you can go through hardening process. You can see that, for instance, LDAP or SMB signature has been enforced on which computer. You can also, so it helps you to choose if relay attacks will be relevant or not. You can also, we often see credential hardening. For instance, the registry key such as run SPPL and credential guard has been enabled. You can get more information regarding additional software installation, such as EDR, so you know what you're dealing with. At the end, GPO elimination can be time-consuming and quite complex because there's a lot of things to take into consideration. You have to check for inheritance, you have to check for enforced link or not. You have to check if computer or user configuration is enabled or disabled. There's also more specific filters, so we have to automate this. There's a lot of tools that try to enumerate group policy objects, such as a well-known Bloodhound, but we notice that it doesn't take every parameter into account. Here, I have an example where within my workstation organizational unit, I have a child container, admin, and admin on the admin container, the organizational unit, the inheritance is blocked. I'm using the same GPO, allow LGP, that I mentioned previously, which allow any domain user to connect on those machines. So I have a workstation 1, which is within the admin container, and the inheritance is blocked. And the GPO, allow LGP, is on the workstation organizational unit. So basically, it prevents any user to connect to my workstation admin. On the right, you have a PowerShell command. When I update my GPOs, and I enumerate the members of the remote desktop user group. And when the GPOs are successfully updated, I can see there's no members, which is quite normal because inheritance has been disabled. And then when I collect the data with Bloodhound, and I ingest it, Bloodhound forget to take into consideration that the inheritance has been blocked on the admin container, and it shows a path from domain user to workstation 1 with the CAN RGP edge, which is false. So we notice there's other tools, but they also don't take every parameter into consideration. So we develop a tool which is called GPO parser, that we parse all GPO configuration parameters that presented earlier. It tries to reveal misconfiguration and privilege relationships. It supports both online and offline analysis. And we try to enrich Bloodhound with useful edge. This way we can create the new edges that we have lost from our GPO collection, such as admin2, CAN-RGP, CAN-PS remote. You will find the tool on the Synactive GitHub right after the talk. So I will give you a quick demo of this one. First, we will try to collect it. We will collect it. Sorry, wrong demo. I will first show the demo that goes online. Okay, so basically you have to, here I'm doing the collection remotely. You can collect GPO with a low privilege user. So I'm specifying the credential, I'm specifying the LDAP, and also the domain controller. It tries to connect, retrieve all the files, and it parse. And here we can see, for instance, this specific GPO, which is called enforced SMB signing, has been applied. You can see there's some specific connection restriction tied to domain admin. You can also assign privilege, for instance, SE debug privilege to the developer groups, and so on. For instance, you can see that the group, all our workstation are workstation admins. You can also perform this reconnaissance offline. So what you have to do is you have to collect all the LDAP data. I will do this LDIP, collect few information regarding the LDAP. I will also need to connect retrieve the policy, which are by default on the sysvol share. I'm retrieving everything here. We can retrieve all the needed files, but here for the presentation, I'll just retrieve everything. And I will pass it locally. So I have to specify where I find the sysvol share and the LDAP folder. And what I also want to mention here, like we can also filter. For instance, we want to know the GPO that's only applied to a specific target. For instance, the specific computer workstation 1. And here, locally, I can see that all the GPO that apply to this specific workstation, and now I can see the same information, but tied to this specific workstation. So basically, it's the same. You can see that domain user can connect through a remote desktop user group. Now I will let my colleague Quentin speak about abusing ACLs.
All right, thank you, Wilfried. So Wilfried explained to you how GPOs are implemented and how you can abuse them to enumerate some security relevant configurations. For my part, I will actually explain to you how we can abuse group policy objects in order to compromise Active Directory objects, so users and computers. And the first way I'm going to do that is with the most standard way you would exploit a GPO in an Active Directory engagement. So let's say you have write access to a GPO with a user. And this is not an uncommon situation. We encounter it pretty often in engagements. This can be T1 accounts. This can result from administration mistakes, etc. And this is actually a very powerful primitive, attack primitive, because when you control a GPO, you can compromise all the objects that are linked, that are included in all linked organizational units, including sub-OS. When you exploit a GPO, what you basically want to do is just leverage some built-in GPO features in order to deploy malicious configurations to the users and computers to which the GPO applies. And you can really deploy a lot of malicious configurations. You can deploy some scheduled tasks, you can deploy some immediate tasks, or you can do something like add a user to a local group, you can transfer files, execute files, setting registry keys, you can define some logon or logoff scripts. What I want to point out is that imagination is really your only limit when you want to exploit a GPO in order to compromise the objects to which it applies. And we have some offensive tooling to exploit GPOs, not so many. We can have something like sharp GPO abuse, PyGPO abuse, GPOnd, or the DRSIT tool suite. But during engagements, we found out that these tools have some limitations that made them pretty difficult to exploit. The main one is the stability and exploit safety consideration. So GPOs are very critical in Active Directory. They are sensitive architecture components, so you really don't want to screw them up. So exploit safety is really important. There was also some lacking in cleanup and revert capabilities. After you exploited, we want to clean up for stealth or just to clean up after yourself. Very often, there was no possibility to create GPOs, to manage links, to target specific objects with your malicious configurations. And more generally, there was a lack of available actions and options that you could configure to exploit your GPO. So we created the group policy backdoor.py tool. This is a Python implementation using only LDAP3 and SMB protocol, so no in-packet for stealth considerations. You can do quite a bunch of things with group policy backdoor. You can create your GPOs, delete them, backup them. You can manage your links. You can inject some customizable configurations. Importantly, you can also leverage the item level targeting feature of GPOs in order to only inject your configuration to specific objects. So if you want to target a specific computer, you can with group policy backdoor. You can also clean up after yourself and revert the actions you performed on clients. So it will be available on GitHub after DEFCON. For it to be a little bit more concrete, let's take a real-world example that we encountered like a few months ago. And let's try to exploit it with group policy backdoor. So we compromised an account a few months back that had write privileges over a pretty interesting GPO, because the GPO was applying to a jump server that was used by domain administrators in order to perform some administrative actions. We did not have any kind of privilege other than the rights on the GPO. We did not even have network access to this jump server. But what we did was that we exploited the GPO in order to add a scheduled task on this jump server. We configured this scheduled task to run in a privileged context using the identity of a domain admin, and the scheduled task only added an account under our control to the domain admins group. And you can see here a pretty interesting thing is that we are exploiting a GPO that applies to a jump server in order to, so to say, trap the jump server so that the scheduled task will trigger when the domain admin connects to it. All right, let's see a quick demo. All right, it's this one. I think it's coming. All right. So let's say that we compromise the user that is called Alloy. You can see here I'm authenticated with Kerberos with Alloy. Alloy has some standard groups. You can see here I enumerate the groups. It is part of the IT support group, quite standard. Let's use group policy backdoor first to enumerate the GPOs of the domain with the enum list GPOs command. You can see there is a bunch of GPOs. The one that interests us is called jump servers hardening. Let's use group policy backdoor to get some more details on this GPO with the GPO details command. All right. The most important thing that we notice is that our current user, Alloy, has write permission over this GPO. This is pretty good. This means that we will be able to exploit it. And this GPO is tied to an organizational unit that is called jump servers. In this jump servers organizational unit, we have the jump server that we are trying to compromise. As you can see here, the AD01 Bastion, which is the jump server that we are trying to exploit. All right, so let's inject our malicious schedule task into the jump server. In order to do that, with group policy backdoor, you define a configuration through an .ini file that specifies what configuration you want to inject into the GPO and what option you want to configure your malicious configuration with. So you can see here, quite standard, we want to inject a scheduled task. We want it to run the cmd.exe program. We want it to add our user Alloy to the domain admins group. We want to impersonate ADM Q-Roland, which is a domain admin that connects to the jump server. And we want to repeat this scheduled task every minute because we don't want to wait. Additionally, you can provide some filters. Here I say, I only want the scheduled task to be defined on the AD01 bastion.com computer and not on anything else, for stealth, for instance. And you just provide a filter with a computer name title. So let's run group policy backdoor with this configuration file, and this will inject our malicious schedule task into the GPO. You can see here we provide the modify command, and we provide the .ini file that I just showed to the jump servers hardening GPO on which we have write access. So we execute group policy backdoor. It does a bunch of stuff. I won't go into details, but it modifies the group policy container. It modifies the group policy template in order to inject your configuration. In Bub, it also bumps the GPO version so that clients will actually update the GPO. And now, all we have to do is, we can see on the domain controller here that the jump servers hardening GPO defined the scheduled task with the group policy management console, just for illustration. So you can see here our scheduled task is there. It is configured to run with a trigger, with an action that adds our user to domain admin, some item level targeting in order to only be defined on the Bastion. All right. So at this point, we would just wait for the Bastion to refresh its GPOs, define the scheduled task, and then add our user to the domain admins group. So that's what we're going to do. We will force the GPO refresh with GPO update because we don't have time to wait for 90 minutes. So yeah, the GPO update command is executed. And you can see right after that our scheduled task will be defined on the jump server, and then the domain admin ADM Q-Roland will execute it and add our user to the domain admins group. You can see here we have the scheduled task defined, running as ADM Q-Roland, and then it's all set. We just have to wait 1 minute, and our user will be actually added to the domain admins group. So I just cut the minute out, but you can see here with an LDIP command that Alloy is now part of the domain admins group. All right, so you did your exploitation, that's great. What you want to do then is clean up after yourself. You want to remove this configuration you injected into the GPO. And group policy backdoor makes it pretty easy because each time it runs, it creates a state folder that has many information about what it did. And you just have to provide this state folder to the clean command in order to clean up after yourself and to remove the configuration that you injected from the GPO. So you can see here, I provide the state folder into the clean command, I execute the command, and it just, again, does a bunch of stuff. I won't go into details, but just removes the configuration from the GPO. All right. So that was, I mean, we have a lot more examples of how we exploited GPOs during engagements. We used it to reach some network-isolated workstations that we could not even pivot to. We used it to enable WinRM and add some firewall exceptions. We also used it to persist in the Active Directory environment after detection. So the good news is that you can just extend group policy backdoor to your use cases to add some more configurations that you want to inject into GPOs. You can do this pretty easily, so don't hesitate to do so. All right, so this was kind of the standard GPO exploitation vector. We are going to dig a little bit deeper, and we're going to see how we can exploit group policy objects via NTLM relaying. A little context about this research. We were, during an engagement, we were able to perform some NTLM relaying to the LDAP service, which is often the case. For instance, you are able to relay HTTP to LDAP, right, in default configurations. And we were able to relay an interesting user that had write privileges over an interesting GPO, and this GPO applied to domain controllers. So because we were relaying to the LDAP service, we had the possibility to modify the group policy container via LDAP, if you remember what Wilfried explains. But we had absolutely no privileges over the SMB share, the group policy templates, on which the GPO configuration files are located. And we were wondering, is this even exploitable? And it turns out that yes, it is, because Wilfried mentioned it also a little bit earlier, but in the group policy container, you have an interesting attribute that is called the GPC file syspath. And it specifies the location of the group policy template as a UNC path. And by default, this will be simply the sysvol share, right? But it is actually possible to specify an arbitrary SMB share location in this attribute. Anything goes. And for Microsoft, this is a legitimate feature, this is expected, but not so much because it crashes the group policy management console. So I guess this is kind of a gray area. So you can see here, I just modify in Windows the GPC file syspath to a random IP address, right? And after 90 minutes, I start to see some objects that are trying to actually authenticate to me in order to fetch the GPT files. So you can just specify anything in the GPC file syspath attribute. And so if you pay attention, we now have an attack vector that you can implement through only NTLM relaying by only modifying the group policy container. The first two steps are pretty standard, so you relay your user to the LDAP service, you interact with the LDAP service as the user. The next step is to modify the GPC file syspath to point to your server. You say basically, yeah, the group policy template is on my machine. You implement an SMB server on your machine that serves malicious group policy template files, for instance, defining a scheduled task that you want to run on the victim. And now you just wait for the object to try to apply the GPO, realize that the configuration files are on your system, and fetch the files on your system, and it will work. So we created a tool that is already available that is called GPODT, and that does just that. I also won't go into details, but there was a main implementation challenge was to implement a working domain joined SMB server, because you can't just provide anonymous access to the objects. They will refuse, modern Windows SMB clients will refuse to actually connect anonymously to a server. So GPODT performs some net logon to overcome this difficulty. All right, time for another demo with the GPODT tool. All right, so we have a domain. We have the domain controller's organizational unit with a GPO that applies to it, which is the DC Corp hardening group policy object, which is a standard group policy object. You have the GUID here. But what is interesting is that the ADOV user has some rights over this GPO. And let's say that we relayed the ADOV user to the LDAP service. We can see here I've spinned off my NTLM relayX, and I relay this user to the LDAP service. And I am interacting with the LDAP service as an ADOV user. Pretty standard. So I spin off the in-packet LDAP shell in order to execute LDAP commands as the ADOV user. To be a little bit more comfortable, I will create a machine account with this LDAP shell that is called GPODT, and I will give all the rights over the group policy container for this machine account with the LDAP shell. So now I'm in a situation that I described earlier. That is to say, the GPODT account has privileges over the group policy container, but nothing over the group policy template. And we'll try to exploit this. We'll try to exploit this to add a local admin to the domain controller, and more specifically, we'll add the GPODT machine account that we created to the local admin group of the domain controller. We can see first that our GPODT account is not yet part of the domain of the local admin group of the domain controller with an SMB client command. You can see here I try to connect to the $C share with GPODT. I got an access denied. This is quite expected. Now let's exploit this situation with GPODT. So the command will look something like this. You specify the GUID of the GPO you want to exploit. You specify the username and password of the user that has rights over the group policy container via LDAP. You specify the command that we want to execute. Here I want to add my GPODT computer account to the local admin group of the domain controller. And then you just press enter. GPODT will do a lot of things, but the most important thing is that it will modify the GPC file syspass attribute to my attacker machine, as you can see here. And now I just have to wait for the domain controller to update their GPOs and fetch the GPT files on my machine. And you can see on the right, I just execute GP update. And as soon as I execute GP update, I have the domain controller trying to authenticate to me to fetch the GPT files, right? And I authenticate it with netlogon, and I provide the malicious GPT files to the domain controller. And it will execute my immediate task that adds my GPODT machine account to the local admin group of the domain controller. As you can see, then now I can SMB client into the $C share of the domain controller. So yeah, I am local admin of the domain controller, which is good news. Thanks. All right, last part, we'll dig even deeper. And it will be the last part. For this section, we'll try to exploit protected organizational units by poisoning the GPO link attribute. A little bit of context. Wilfried explained to you that GPOs are linked right to organizational units through the GP link attribute. That looks something like what I put on the slide. And when you have write access to an organizational unit, Petros Koutroumpis showed a few years back that it is possible to add a GP-link item in order to simulate a malicious GPO that objects of the organizational unit would try to apply. And why is it interesting? It is interesting in comparison with other organizational units attack vector that we previously have. So previously, we only had one attack vector that was targeting organizational units that relied on ACL inheritance. And what you did was basically to add a generic role, for instance, ACL, to the organizational unit container, and it was by default inherited by all the objects of the OU, which was quite neat and simple and also reliable. But this attack vector had some pretty heavy limitations. It necessitated some high privileges, so write the ACL, and most importantly, it could not be used against what we call in Active Directory protected objects that has the admin count equal to 1 LDAP attribute, because for these objects, ACL inheritance from the parent container is disabled. So GP-link poisoning is pretty interesting because it can be exploited with very limited privileges over the organizational unit. You only need to be able to write the GP-link attribute, and it also works for privileged objects such as domain admins, right? So how does it work? What is precisely this attack? So what you do is that you modify the GP-link attribute in order, as I said, to inject an additional GPO link to the OU. And as you can see here, your injected item will not point to the domain, but to a domain name that resolves to your machine. Here, I added a GP-link item that points to attacker.cop.com instead of cop.com. And when the objects are fetching the GPOs they should apply because they are linked to their OUs, they will try to apply this GPO, and then the attacker should only simulate a group policy container, simulate a group policy template, and just execute malicious configurations through this injected GPO. So we created a tool that we called UNED to automate the attack. It is available on GitHub. We also added 2 edges to Bloodhound, so the write GP-link and generic write edges on organizational units because they are exploitable through the attack vector I just described. All right, let's just describe it more visually. So first, you have a user that can modify, that can write the GP-link of an OU, right, first step. Then you poison the GP-link, you add an item to the GP-link. Third, your object will try to fetch their group policy container on your machine. You simulate a group policy container. And finally, fourth, the objects will also try to fetch the group policy template on your machine. You simulate a group policy template, and they apply your malicious configurations. All right, let's have the last demonstration of the session with the UNED tool. All right. So we have a domain here. All right, does it work? I mean, it's weird. Right, just a second. Okay, so we have our domain. We have the PKI servers, organizational unit, that contains a computer that is called AD01 PKI. So we'll try to, so on this PKI servers, organizational unit, we have a user that we dubbed N. Augustine that will have some limited rights. She will only have the rights that is called manage GP link, which allows her to, as you can see here, manage group policy links on this OU. And so we'll assume that we compromise the N. Augustine user, and we'll try to abuse this privilege she has on the organizational unit of PKI servers. All right, so we'll try to exploit it in order to add the N. Augustine user to the local admin group of the PKI server AD01 PKI. So you can see here first, the PKI servers organizational units only has one GP link, legitimate GPO. All right, and the N. Augustine user is not a local admin of the AD01 PKI computer. As you can see here, access denied. All right, so let's exploit this privilege with UNED. UNED takes a config.ini file that specifies some configurations. There are a bunch of them, but most importantly, you specify the target organizational unit. You specify the user that has the right to modify the GP-link attribute, and you specify the command you want to run on child objects. As you can see here, I'm adding the N. Augustine user to the local admin group of my target. There are a bunch of other configurations that doesn't matter. We are spinning off a fake DC in order to simulate a group policy container, but I won't go into details here. All right, so let's execute UNED with this configuration. And you can see that there are a bunch of things that UNED does. It sets up port forwarding to simulate a GPC. Doesn't matter. The most important thing is that it adds a GP-link attribute into the organizational unit. As you can see here, if I do some LDIP, I have another GP-link that was added here that points to uned.com.com, right? And uned.com.com points to my machine. And so what happens is what I described earlier. The objects will try to apply the GPO by thinking that I am the LDAP server, and I will simulate a group policy container. So on the right, on the AD01 PKI server, I will just execute a GPO update command. And as soon as I do that, you can see on the left, on the UNED side, that I will have a communication from the AD01 PKI server that tries to authenticate to me, first to fetch the GPC, so the LDAP part, and I will answer to the computer, and then for the GPT, the group policy template, and I will again authenticate it and respond with the appropriate files. And finally, we can see that the attack worked because the N. Augustine user is now local admin of the AD01 PKI computer. As you can see, I'm connecting to the CDOLR share, and I am local admin of this computer. So we have used this GP-link write permission. All right, thanks. All right, just a few words to conclude. So we believe that risks associated with GPOs are pretty much underestimated today. GPOs are very powerful just for enumeration, as Wilfried showed you, but also for exploitation primitives. There are a lot of exploitation primitives on GPOs, but also on organizational units. And of course, we aim to provide a better understanding of how GPOs work, how you can enumerate stuff from them, how you can exploit objects from them. And GPOs are just fun, and don't hesitate to research on it. Thank you. Don't hesitate if you have any question, we're free to chat.
Thank you.